Hello and welcome back. In this example, we're going to take a look at related rates, and we're starting off with a very simple example where we're going to have a rectangular piece of material that is going to be stretched and contracted, and we want to look at the rate of change of the area. So if possible, one of the best things you could do in a problem like this is to go through and draw a quick little diagram of what's happening. So for our rectangle, we're going to have our length and our width. And remember that these are now going to be functions of time because they are both changing. So I like to use function notation with each of these to remind myself that I have quantities that are changing with time. And we know the area formula. We know that the area for any rectangle is always the length times the width. So in our case, the area at time t is the product of the length at time t and the width at time t. And they tell us that we have a moment in time, which is 5 seconds, and at that moment we have a length of 12 meters and a width that is 8 meters. And we have some rates of change of both the length and the width given to us. So after we have our formula and we have our relationships between our variables stated, we can now take the derivative. So a prime of t, using our product rule, is going to be L prime of t times W of t plus L of t times W prime of t. And now we can go in and substitute that at the moment of 5 seconds. We can now substitute in all of these values. And it's very important when you're doing a substitution to include units. So L prime is the rate of change of the length, and that was given to us as 4 meters per second. And then we have the width at this time, and that is given to us as 8 meters. And then we have the length at this time, which was given to us as 12 meters. And then the rate of change of the width is going to be a negative 2 meters per second because it's decreasing. So negative 2 meters per second. And when we calculate this out, we're going to have 32 square meters per second minus 24 square meters per second. Very important to observe here that these units are like units, which means that we can go through and now subtract or add them as necessary. In this case, we're subtracting. So 32 take away 24 is going to be 8 square meters per second. And that is the rate of change of the area of this rectangular box. Again, very important to make sure you always check your units. It is 8 meters per second, which makes sense. It's a rate of change of area per time. And that is our first example of related rates.